Hello, my name is Christina Baccio, and this is Baking with Batch 101. Today we will be learning about spectroscopy and the unique form of baking. First I will go through the steps, and then we will try a practice problem. The first step is 2n plus 2, the n being the carbon. Step 2, you count your hydrogens. If you have any halogens, you add it, and if you have any nitrogens, you subtract it, and if you have oxygens, you ignore it. Step 3, you subtract step 1 minus step 2 divided by 2. The result is your degree of unsaturation. Now we will make some pancakes. The practice problem we will be doing today is C5H4N2O. The C's are represented by the food coloring. The H's will be represented by the honey or the syrup. The N will be represented by the Nutella. And the O will be represented by the pancake mix. To begin step 1, since there are 5 carbons in the molecular formula, we are going to multiply 5 times 2 and then add 2, giving us 12 drops of food coloring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I will begin to mix. Now for step 2, since there are 4 hydrogens in the molecular formula, I'm going to put 4 drops of honey into this measuring cup. 1, 2, 3, 4. Now, since there are 2 nitrogens in this molecular formula, I will proceed to put 2 scoops of Nutella into this measuring cup. Just kidding. If you recall, in the beginning of this video, I said the nitrogens you do not need. You're supposed to subtract them from the hydrogens, therefore giving us 4 minus 2 with 2 for step 2. 3, we will not be needing the honey, because we would have to subtract the honey from the 12 drops of food coloring that I already put in the pancake mix, and then divide it by 2, giving us 5 pancakes, or 5 degrees of unsaturation.
Today I will be teaching you how to read the IR, but I'll show it on a cake. So we're going to start with when we have lines in the 3000. If we have a bump that goes like this, that means that you have an OH on it. And when we have something like a V, that means that we have NH in our formula. Now, when we have a W, well, sort of a W, that means that we have an N and we have 2 H's. Okay? Now, if we have something in 3000, we ignore that because it's not important right now. When we have at 2200, we will have something like a V. That means that you have triple bonds there. It can be either a C, triple bond, C, or you can have a C, triple bond, N. Okay, now we move to 1700. 1700, it's pretty obvious when you have a line there. You have a long V on it. And this one, it's a C double bond O. Now this is a carboxylic group. Alright, now at 1600 we'll have like a little V also. And for this one, we would have a benzene ring. And at 1000, you usually have, if you have a long V on it, you just ignore it. Don't pay attention to it. And that's how you read an IR.
Hey everyone, today I'm going to be teaching you the NMR, and we have a line from 0 to 12. So when we first start off, if you see a line in between 11 to 12, you have an O double bond C with an OH attached. So we made M&Ms and Twizzlers. So right now we have the oxygen with the 2 lone pairs, which are very important, the double bond C, and attached to it is an O with the 2 lone pairs and a hydrogen.
There is a line between 10 and 9. It is a C double bond O with an H attached to it. O represents oxygen with 2 lone pairs of electrons and a double bond. Attached to the double bond is a C, which is carbon, and attached to the carbon is a hydrogen. This is an aldehyde.
At the NMR, and you notice that there is a bump with a 2 above it, this means that it is a NH2. But when you see a bump with a 1 on it, that means that it is OH or NH. And for the OH, don't forget the lone pairs. And these bumps can be anywhere on the line. So if you see a line between 8 and 6, this will be known as a benzene ring. And for the benzene ring, there are 6 carbons, so the carbons would be a carbon right here, right here, right here, right here, right here, and right here. And then connected to all of those carbons are 1 H's that are shown right there.
There is a line between 6 and 5. It is a C double bond C with an H attached to it. This is the double bond. These are the 2 C's, and this is the H.
When you see 4.1 and you notice that there is a line next to it, this will be an O double bond C with an OCH2. And today we drew an O with the double bond and the 2 lone pairs. And then we have a C attached to it with an O and the lone pairs. And then another C that's connected to 2 H's.
When you see lines in the NMR, this means these lines here represent hydrogens. And the number on top of it also represents hydrogens. First, you do the number on top. You do a carbon. You draw your lines to represent the H's. Now, you know that you have another carbon next to it. But with this one, you take the lines and you minus 1 from it. So you have 3 hydrogens attached to them. And then you just connect them. And the same thing, and if you want to just verify that you're right, you do it for the other one next to it. You have a carbon with 3 H's, 1, 2, 3. And then the one next to it has 1, 2, 3, plus 1, that's 4.
Learned everything you possibly wanted to know about spectroscopy.
That's right.